Good day everyone, I'm Flordelize Felecio and I am here to report our assigned topic, which is formal logic and inference. So let's start. Formal logic. Formal logic, the study of system of deductive arguments in which symbols are used to present precisely defined categories of expressions. Formal logic, also known as symbolic logic in logic, is concerned with proposition forms as well as with inference forms. The study of proposition forms can in fact be made to include inference forms in the following way. Let the premises of any given inference form be abbreviated by alpha and its conclusion by beta. So, a common example of formal logic is the use of a syllogism. To explain those connections, a syllogism is a form of reasoning which draws conclusion based on two given premises. In which syllogism there are two premises and one conclusion that is drawn based on the given information. Example of syllogism: all mammals are animals. All elephants are mammals. Therefore, all elephants are animals. The more general premises is called the major premises. All mammals are animals. The more specific premises is called the minor premises. All elephant are mammals. So, moto siya example sa syllogism. Next, what is inference? So, the inference is finding a conclusion of result based on any data events and in information. Usually, there will be a set of conditions and the conclusion is made which satisfies all the given conditions are true. The conclusion is made according to the inference rules. Any artificial intelligence agents or an intelligent system uses the inference engine to find a better result of output. So, inference may be defined as the process of drawing conclusion based on evidence and reasoning. It lies at the heart of the scientific method, for it covers the principles and methods by which we use data to learn about observable phenomena. Derivations of conclusion from given information or premises by any acceptable form of reasoning. Example of inference is using observation and background to search a logical conclusion. You probably practice inference every day. For example, if you see someone eating a new food and he or she makes a face, then you infer he does not like it. Or if someone slams a door, you can infer that she is upset about something. So, ang inference is kung unsay imong kinahanglan nakit-an kung conclude ka og kanta og kaning first example, someone eating, if makit-an nga lucky or badge nga kaon then ug kuan siya insay forma siyang naong ug nagisiba giganahan na siya kaon. So, mo to siya sa inference example. Next is conditional inference. New conditional statement can be generated from existing ones. Consider the conditional statement A impulse B, A impulse B, with logical connective implication. The expression says that if statement AA is true, then statement BB must be true. Now, the three conditional statements that can be generated from this are given to next slide. So, conditional statement inference. Conditional statement inference is a branch of statistical inference in which observed data is reduced using either sufficient or ancillary statistic. This often simplifies inference about the parameters. Ang ato ang example is inighuman na sa 3 ka inference statement. Next, converse. The converse statement is opposite to the implication. The expressions for the converse is B impulse AB impulse A. So, mo ni siya. Ang pagbasa dani sa arrow is impulse. This is must be B impulse AB impulse A. So, ang converse statement is opposite ni siya sa implication. So, next, contrapositive. The contrapositive follow the negation rule. It is the negation of statement in converse. So, ano siya negation? The negation of A, B is not A, not B, not A, not B, and the contrapositive expression is A is not B, impulse not B, not A, not B, impulse not A. That represent if not B, then not A. If not B, then not A. So, ang contrapositive is nag-follow ni siya sa negation rule. Ano siya ang negation rule is meaning A, B is not A, not B, not A, not B. Anya ang contrapositive expression is meaning not B, impulse, not A, impulse, not B, impulse, not A, impulse, not B. So, mo na siya. So, next, inverse. The inverse statement follow the negations of statement in application. The expressions of inverse is mo na siya ang expression sa inverse. Not A, impulse, not B, not A, impulse, not B. So, mo to siya. So, maghatag og example sa kaning conditional statement and inference. If today is Wednesday, then yesterday was Tuesday. So, mana siya ang example. If today is Wednesday, then yesterday was Wednesday. Ang yang hypothesis is, if today is Wednesday, so our conclusion must follow. Then, yesterday was Tuesday. So, mana siya na ang atong conclusion of follow sa then kung Wednesday pag karon, then pagkagahapon is Tuesday. So, the conserve is found by rearranging the hypothesis and conclusion as Matlanet accurately states. So, mo to siya. Next is first order logic inference rules for quantifier. Universal generalization. It is a rule that states that if the premises is correct or valid or any elements CC in the universe of discourse, we have a conclusion. This rule is used to present that every element has a similar property. So, kaning universal generalization is kuha ni siya, we have mag-conclude ni siya. So, ang elements din nag-represent ni siya na ang every elements ka similar property ra. Next, universal instantation. This is also known as universal elimination. This can be used multiple times to add new sentence. In IU, any sentence can be inferred by substituting a ground terminal for the variable. So, kani UI is used to add new sentence multiple times. So, ano siya ang and it is also known as universal elimination. Next, existential introduction. This is also known as existential generalization. According to this rule, elements C exist in the universe of discourse. Q is the property of the universe of discourse. So by this, it states that everything exists in the universe that has the property Q. So, ang existential introduction na known po ni siya as existential generalization. Ang iyang sa rule niya is element C exists in the universe of discourse. So, it states that some things exist in the universe has the property Q. So, mana to siya. Example, consider Ron got good marks in English. So, we can infer that someone got good marks in English. So, si Ron nakakuha og laming grado sa English, then ato ang infer nga naay someone nga nakakuha og nindot nga grado sa English.
Hello everyone. Before I proceed, let me introduce you. First myself, my name is Lindon Libres. In this part, I'm going to discuss rules of inference. Rules of inference. Inference rules are templates for generating authentic arguments. These rules are enforced to develop proofs in AI. These proofs are usually the sequence of conclusions. There are 7 types of inference in artificial intelligence. First, modus ponens. The modus ponens is based on the implication. This is read by A impulse B, which means that if AA is true, then BB must be true. The rule states that if A impulse B and AA is true, then BB will be true. Example, statement 1, the room is dirty, then I will have to clean up. So A impulse B. So sa statement 2, the room is dirty. Ang conclusion na ni kay true man ang A o B. So the conclusion is I will have to clean up. So that's modus ponens. And the next is modus tollens. Modus tollens is the follow the negation rules. That means if E equals BE is true and not B is true, then not E also be true. So na-negation na ni guys. So example, statement 1, if rain that if rains, then the clothes will be wet. So sa statement 2, clothes are not wet. So during a part, kuha na negation. So sayop na. Then the conclusion is which infers that it has not rained. So nagkakuha na sila. Then next, hypothetical syllogism. The hypothetical syllogism state that if A impulse B is true and B impulse C is true, then A impulse C and impulse C will definitely be true. So diri mag taas-taas na siya nga sequence. So diri, if you have my car, then you can take it the key. In statement 2, if you can take its key, then you can go to the palace. So if you have my car, then you can go to the palace. So ang conclusion ani gi-connect ra niya tanan, pero ang result ani true. Then dire addition. In addition rules for the two statement E B E B, if E is true, then will be true. So tanan din nga statement, so dapat ma-true. So example, I have a banana milkshake, I have a mango juice. So ang conclusion din I have banana milkshake and mango juice. So muraragi true ang duha ka statement, pero ang conclusion ana niya gi-combine ra. That's addition. So next, arita simplification. In propositional logic, conjunction elimination, also called an elimination, that sign is elimination of simplification, is a valid immediate inference argument form and rule of inference which makes the inference that if the conjunction A and B is true, then A is true and B is true. The rule makes it possible to shorten longer proofs by deriving one of a conjunction of a line by itself. So diri murag sa word nga simplification, so iyarang gi simplify. So ang example statement, I will make a coffee and I will read a book. So ang conclusion din therefore I will read a book. So gimubo ra niya. Then last, resolution. If a rule of inference leading to a refutation complete theory providing techniques of sentence in propositional logic and first order logic for propositional logic, systematically applying the resolution rules act as a decision procedure for a formula and satisfiability solving the complement of the Boolean satisfiability problem. For example, it's raining, or I will make a tea. So sa statement 2, it's raining or I will read a book. Therefore, I will make a tea or I will read a book. So dire murag naa kay kapilian. So, a short recap, guys. The rules of inference are formally valid arguments. Any arguments with the same form as a rule of inference is a formally valid argument. A formally valid argument is one whose form guarantees that if its conclusion necessarily follow from its premises, so long as formally valid argument has true premises, its conclusion will also be true.